All right, we're looking at this word problem. The idea here is building a raked stage, which I did not know what it was before this problem. A rake stage is a stage built up at an angle. So this little picture here is kind of supposed to be showing us, right, these are the stage lights. And then see how the stage from the front is going up higher at the back. It's kind of at an angle, so the people at the top are people at the back of the stage are going to be easier to see in the audience. All right, so they give us some information. The stage is 30 feet long, and we can see that represented right here in the picture. That's the actual top of the stage is 30 feet long. It's got a total rise of 2 feet. So that's this piece right here. It's 2 feet tall in the back. There is a safety issue here, like the thing can't be too steep or people will topple forward. So they want the degree value to be 5 degrees or less. So we want to know if this is safe the way that they designed it. So we know, and it's typically easier to draw sometimes your own picture. So we know we have this stage coming up 30 feet long, 2 feet down. It's a right triangle. We're trying to figure out what this angle is right here to find out if it's safe. We need it to be 5 degrees or less. So we'll do some trig here to figure this out because this is an unknown angle. So I would recommend using our mnemonic. So, TOA to help us determine from what we have this 30 feet and this 2 feet and then this angle right here. Well, if we look at it from that green angle, we have to go across the triangle to 2, so that's the opposite side. And then 30 is right across from the right angle. So this is the hypotenuse and this is the opposite. H and O, that's right here, which means we are going to use the sine ratio. So we'll set up this equation as the sine of the angle, which we don't know, so the sine of theta, and it's going to equal the ratio, right? These are how all the trig equations get structured. Sine, cosine, or tangent of an angle equals a fraction. Opposite over hypotenuse, so it's 2 over 30. And then we want to figure out that angle. Well, theta is what we want. Like our final answer should be like theta is some degree value. Right now, theta is trapped inside sine. We need to undo the sine. You need to do the inverse sine. So in theory, here I'll kind of show you that we do this on both sides. In theory, we're really doing this on both sides of the equation. We're going to do the inverse sine of here, and we're going to do the inverse sine of all of that. The reason that we do that is the inverse sine and the sine cancel out, right? They're inverse operations. They undo each other. So really all that we want to focus on here is that theta is the inverse sine of 2 over 30. And that can go directly into our calculator. So we just type that in. You want to make sure that you're in the right setting. I always check tangent of 45. Make sure the calculator gives me 1. Depending on your calculator setting, you can also just make sure you're in the right mode. I'm in degree. So again, I'm going to do the inverse sine of 2 over 30. We can set it here. We can see both. It's a secondary feature, so I do need to do second, and then that sine what looks like to the negative 1. 2 divided by 30. Hit enter, and that's about 3.8. So it's about 3.8 degrees. I'll write that down here. Theta is about 3.8 degrees. I gave myself a space there. I might as well put it in that space as well. So the question, though, really had to do with safety. And the parameters here was that angle needed to be 5 degrees or less in order to be safe. Well, 3.8 is definitely less than 5. So we can say definitively here that this stage is safe. That would be your final answer. Hope this is helpful. Message me anytime with questions.